Challenger 75 is the newest addition to the revolutionary line of belted ag tractors designed and built by Caterpillar. Its older sibling, the Challenger 65, has won numerous awards for innovative technological excellence. But ingenious design alone is no guarantee of success. How the design is executed, the way the machine is built, is equally important. The productive reputation attributed to these machines is a direct result of Caterpillar's dedication to quality, uncommon quality in both design and manufacture. To see how they are built is to better understand that reputation, a reputation built on quality. By preference, we build machines which, on the whole, are rather difficult to make. Assembly line methods adopted by Caterpillar assure consistency of manufacture. Each component is built utilizing the same sophisticated tooling. The Challenger contains many fabricated parts which are subjected to bending and twisting forces. That's why we use steel transition castings at high stress points. This allows connecting welds to be made at low stress areas for better weld integrity and increased durability. This facility fabricates the frame and assembles the machine. Most other components come from nearby Caterpillar plants. For example, the Mossville plant near Peoria, Illinois, supplies their specialty, engines. Mossville, in turn, receives unmachined engine blocks and heads from Caterpillar's Mapleton foundry. This full-scale approach toward technology has placed us at the leading edge of many manufacturing technologies, such as forging, heat treating, and flexible manufacturing systems. We apply high technology before metal is ever poured in our foundry and keep it working until the last bolt is tightened. The pursuit of consistent quality is why we cast much of our own gray iron in this ultra-modern facility. Electric induction melting in a 25-ton furnace is one measure of this control. Each smelting is analyzed to ensure specific parameters are met. A part can be no better than the material it's made of. Heat treating of load-bearing surfaces is another area where we spend a little more time and a little more effort. Our specialists, backed by years of experience, do more heat treating on more parts than anyone else. Some of our processes are patented. Many others are so valuable, we'd rather keep them a secret. Each part is under close scrutiny at every stage. If a flaw is found, the component is taken to the metallurgical laboratory. Here, a scanning electron beam microscope is being used to determine what caused the fracture and how it can be prevented in the future. The Challenger's engines are built at the Mossville plant. As we said before, engines are their specialty. Throughout the buildup, the individual components are constantly examined. Design criteria validated again when they become part of an assembly. Inspectors check each piece and have authority to reject anything not up to Caterpillar standards. After all this, and before the engine is shipped, is attached to a dynamometer, slowly turned over to carefully pre-oil the unit, then fired up and run under various light loads and speeds for initial break-in. engine is then run through a battery of tests to certify that it's 100% operational. Back on the Challenger assembly line, it isn't just the moving parts that are getting close scrutiny. The frame, a welded fabrication consisting of steel castings and high-strength steel plates, is a box section design. Two fabricated C-channel box section rails are tied together by an L-shaped brace and front axle saddle. Each rail is attached to the fabricated differential case by hidden steel castings, providing structural rigidity to the overall structure. This frame is designed and built to be trouble-free for the life of the Challenger. Smaller components are assembled on sidelines or in other Caterpillar plants. Some parts are made by subcontractors, but before any arrive at this point, they have been inspected and tested. They'll be checked again. As components shaped on the sub-assembly lines begin moving onto the main line, they blend into an orderly progression of parts whose whole is somehow greater than that of its parts. Extra design touches are seen everywhere. For example, hydraulic and electric lines are never routed together because in the event of an electrical short, the hydraulic line could provide a source of flammable material. Many competitors do not follow this precaution. All harness connectors are protected against moisture, dirt, and fatigue failures through the use of Sure-Seal connectors. All Caterpillar wiring harnesses are enclosed in one or more layers of nylon braid. A single layer of braid provides 8.8 times the abrasion resistance of black vinyl tape. All terminal connectors have either molded or shrink-on insulation to prevent shorting and improve fatigue properties. And the hydraulics are equally well thought out. The machine is plumbed with Caterpillar's exclusive XT hose. The XT coupling line is equipped with an O-ring face seal, which is easy to install and can be used over and over again. The hoses themselves are made of fabric-reinforced polymer compounds, built to withstand high pressures and temperatures for safe operation from -40 to over 250 degrees Fahrenheit. Top-of-the-line XT6 steering hose handles high-pressure oil flow in the unique differential steering system. All hydraulic lines use metal clamps to keep them aligned. These clamps use a neoprene coating to protect the hoses. This is unlike our competitors who often use ties to keep their lines secure. Clearly, the most obvious distinguishing feature on the Challenger is the rubber-belted track. What is not so obvious is that the mobile track setup is a total traction system comprising not only rubber belts, but also rubber-rimmed steel drive wheels, 8 mid-wheels mounted on 2 minor and 1 major bogie, an air spring, and a load tensioning mechanism. The mobile track system has proven both effective and dependable, a testament to its build quality as well as its design. The belt itself is built by Caterpillar, and while many of its construction processes are proprietary, quite a bit can be revealed about its design. Tensile strength is provided by a flexible steel cable, the 0-degree cable, located just beneath the inside surface of the belt. Three other sets of cables are laid at various angles between the 0-degree cables and the outside surface of the belt. They provide lateral support and protect the main inner cable. Each belt is driven by a pair of rubber-covered steel rear drive wheels. The rubber is bonded to the wheel by a special process to provide a friction medium between the rim and the belt. Deep grooves purge any wet material. The bogie system ensures weight is equally distributed along all mid-wheels. The major bogie is air suspended. The airbag acts like a spring, absorbing shock loads and equalizing the load on the mid-wheels. This improves tractive efficiency and reduces soil compaction. Obviously, there's more to mobile track than a rubber belt. Its effectiveness owes as much to the way it's built as to its engineering. To understand this, all that is necessary is to examine the sturdy individual components. The transmission was designed exclusively for ag applications. It is a power shift direct drive unit which offers maximum fuel efficiency with ease of operation. In the Challenger, the closely spaced 10-speed gear selection provides precise implement matching in the tillage range of over 4 to 8 miles per hour. The transmission is designed to go between 8 to 12,000 hours before rebuild. Teaming this exclusive power shift transmission with the Challenger's specific engine configurations creates a combination of precision power delivery and economic operation unparalleled in the ag industry. When these assemblies are mated to the unique differential steer final drive, the total effect is unquestionably greater than the sum of the individual parts. The Challenger is truly an outstanding design. And the innovative engineering, the quality of materials, and the careful assembly process all reflect Caterpillar's pride in their creation. Both Challengers are above all else extremely well built. It's reflected in the use of box section frames with extra casting material in potential high stress areas. It's easily seen in the cast steel bogies with their maximized weight to strength ratios, in the weld locations in low stress areas, and in seemingly insignificant items like extra support for electrical wiring. It's all part of the way we build things. We feel attention to detail in design and manufacture is essential. The result is a tractor ready to work when it arrives on the farm, a tractor you can count on to be reliable throughout its useful life. At Caterpillar, we concentrate on making things right, even if the process takes a little longer and requires more effort. We feel that attention to detail in design and manufacture can make a difference. That difference has got a name around here. We call it Challenger.